Alright, now let's do addition and subtraction using Stata. Let's first create let's do a 3x2 matrix and call it A. So let's do mat input A equals, and let's give it values 3, 2, 1, 4, and 6, 2. And let's see that we did that one correctly. Alright. Now, let's create a 3x2 matrix B. So mat B equals, and let's give it the values of 7, 6, and then 0, 5, and the last row 3 and 9. Mat list B. Okay, 7, 6, 0, 5, 3, 9. Now let's add them together. So let's do addition. What we have to do is do matrix define, and let's have a matrix C be equal to A plus B. And then we want to see what that looks like. Oops. So we have 10, 8, 1, 9, 9, 11, which is what we got when we did this by hand. And now let's do subtraction. Now you don't actually have to do define either, but it just helps you know that when you do define, you're calculating matrix results using other matrices, but you don't actually have to put that. So let's do D equals A minus B, and we're going to look at D. So when you subtract B from A, you get -4, -4, 1, -1, 3, -7, which is what we got by hand. Now you can apply this to data analysis. You can obtain deviation scores. So let's say we have a matrix of data, and we'll call it matrix X, and have it be equal to the values that we had written down: 10, 14, then 7, 8, 3, 6, 3, 5, and 2, 7. And let's look at that. Okay. Now, previously we calculated the mean, and it was called X bar, the mean of each of the columns, and we got the following values. So the mean of column 1 is 5, and the mean of column 2 is 8. So basically, in all 5 rows, you'd have the values 5, 8. And let's look at that. Make sure we did that correctly. You have 5 and 8 going down. So now, using what we just learned, we can subtract X bar from X to get deviation scores, and we'll call that small x. So small x will equal our large X minus X bar, and we want to take a look at that. And there you go. We have deviation scores: 5, 6, 2, 0, -2, -2, -2, -3, -3, -1, which is what we got by hand. And that's how you do addition and subtraction using Stata.